Hello and welcome back to the lab. Today on the bench we have a really neat piece of Tektronix history and also the product that never was. This particular piece is in a real interesting spot in the development process. You can tell by looking at the front panel it's not quite finished. It still looks a little rough. We'll zoom in a bit. Some of these buttons are hand labeled. I have to be really careful, and when we fire this up I got to put some gloves on because the ink will rub off on hands. It is not a production unit and never was. This is a engineering sample of an FG506 sweep generator. This particular unit was designed to cover 10 hertz to 100 kilohertz, so was very much designed for audio, and it did a linear-based or a logarithmic-based sweep. So you could actually set this unit up to sweep 4 decades of frequencies to do bode plots and things like that on scopes. We'll take a look at some of the front panel controls. The top knob sets the start frequency. The bottom knob sets the stop frequency, so we have a 1 hertz with a multiplier and a 2 hertz with a multiplier. Looks like the slowest this could be set is it would sweep from 1 hertz to 2 hertz, or from 10 hertz to 20 hertz, and that would be about it. We have sine, triangle, and square wave buttons. Everything's working there. Multipliers 10, 100, and 1000x. Power LED, we have a sweep rate control, which essentially is just controlling how fast the sweep is bouncing back and forth, which we'll see. I did get permission from the owner of this. I do not own this unit, but I did get permission to fire this up, so we'll actually plug this in, turn this on, and see it operate if it does. We have sweep blanking. Now, one of the ways this thing does work is it will sweep up and then it'll sweep down. So the sweep blanking cuts out that sweep down. It'll actually collapse the sweep, stop sweeping, and then when it does the increasing sweep, it'll go back and roll through it. So it essentially cuts out the decreasing sweep. We do have an external sweep, so because it's a voltage control frequency, it's a VCF, we could put a voltage on here and it would control the sweep oscillator frequency inside the unit. We have a sweep duration out. This is essentially a gating control. So what you can do is you can trigger a scope off of this and then use this to write bode plots on a scope so you can actually see the response over frequency of, say, an amplifier under test, things like that. Output amplitude and the main output, so your device under test gets hooked up here, and this sets the main output, which it has roughly 20 volts peak-to-peak output. So a pretty stout drive, and I do believe that's in 50 ohms. So it's actually got a pretty stout drive power coming out, so it'll do 20 volts peak to peak into 50 ohms when it's working correctly. There are 2 switches behind these buttons that enable the start and stop frequency. So if you uncheck the stop frequency, it'll stop sweeping. Uncheck the start frequency, oscillator just kind of dies. But so you can set that up. In the later edition, this is in the middle of production. Well, can't say production, the middle of testing. There were 2 additional units that were built after this. These buttons got a lot bigger and a lot more pronounced, and in this case, these buttons are actually bad. They've broken away of the switch in that one, so they just grabbed onto this knurled end, and that was the switch button. But they have they've come out. I can manually actuate the switches inside and get everything going. We're going to take extreme care on this because there's not many examples of this thing left. Actually, I only know where 2 of them are, and one of them is here on the bench. So do not run out and look for one of these. This isn't going to be something you're going to be able to add to the collection. Only 6 of these were ever made, so we have 1 of 6. This particular unit is actually engineering sample 4. We have the 4th in a line of 6, and there was even more, because I got to see the 6th one. There were more design changes before it even, just in 2 more iterations. Even the front panel changed. Pulling the covers off, we have a classic Tech TM500 architecture. Because this wasn't a production unit, this would have been hand-fitted and hand-assembled in the engineering department as opposed to the production department. We can see a little bit of that. Right here we have a ground leg. This actually follows a trace on the circuit board, but apparently the trace wasn't working as well as it should have, so we have a flying ground leg here that's grounding to give some of these components a couple of resistors. Yeah, just a couple of resistors, really, but give the resistors a better ground. These are the two switches that are actually broken on this unit, so I can actually actuate them manually, but the push buttons from the front no longer function. I don't see any problems with the tag tantalums or anything like that. Everything looks okay. Nothing's cracked, split, burned, broken, or busted. And I did get permission from this unit's owner to power it up, so we're going to do that a little bit later in the video after we take a look at it, after we finish taking a look at it. We also have, this package is pretty high up. Actually, that looks like it might be socketed, but the component wasn't actually cut down, put closer to the board. Just part of the engineering process. Nowadays, everything seems to be in test even after it hits production. We have some more hand-adjusted parts here. Actually, that's, yeah, so we have this package here. Eight leg package? Yeah, 8-leg package. Let's see what that part is. We have another one on the back. The one on the back is a 741HC. We have some capacitance added there, probably to stabilize a few things. These might be the critical capacitors for the way the circuit functions here. Yeah, I don't see a matched pair of caps anywhere else. So this circuit, the heart of this circuit is a triangle wave dual slope oscillator. So it slopes up and then it slopes down. And it, from ground reference, it goes positive and it goes negative. And the symmetry of that waveform is highly critical to the function of the way this unit operates. So we will take a look at that and see how it might be going. There is no service documentation for this. We're kind of flying without a calibration list or anything like that. That documentation was never created because this particular unit was never put into production. The reason it wasn't put into production was it overlapped with the FG504, I believe. So let's take a look at this thing, get it fired up, and see if we can't get some sweeps happening. All right, we have the unit on the bench. Now we have voltage. Let's give it some power and see. Well, we don't have anything on the scope quite yet. Speed that up a little bit. Let's push the go button. Well, it's gone high, but we're sweeping it like, or it's buzzing at 10 hertz, so it's not even sweeping, which is fine. Let's speed it up a bit. Okay, so it's not quite running. Let's see if we enable the bottom output. All right, we have the bottom output turned on. Oh, you can't sweep the, well, you can set it that way, it just doesn't like it. Okay. Let's speed this up a bit. Well, that looks better. Oh, not sinusoidal. Okay, so our if I flip this over to a triangle wave, our triangle symmetry is not correct. So let's see if we can't tweak that a bit. Well, that looks a lot better. How's our symmetry on the square wave looking now? Better. It looks like it's trying to move. Let me flip it to the Rigel and see what's happening. Oh, my duty cycle was good, but not great. Let's see if we can't make that a bit better. Okay, we're 0.2% or 0.12% out. It's about as good as we're going to get it. It's trying to sweep. And we have a bit of dirty controls. It's really trying hard to sweep. If I hold the switch in, I'll slow the sweep down. But if I hold the switch at just the right position, it'll go. So we have some dirty contacts in the switches. The switch that is dirty, to get it to go, I'm holding in this top switch. That's what's getting it to play nice. So we definitely have some dirty contacts in these two switches. These switches need to be cleaned up, and these switches need to be cleaned up too. That is not a shock. Every TM unit that's built with these switches does need to be cleaned. Nothing normal there. But the unit is really trying to work. Like, I'm pretty sure if we cleaned up the switches and everything like that, this unit would come back to function. Like, even me just actuating the switch a bunch of times is almost getting it to go. But that sine wave actually looks pretty good. Let's see what kind of distortion we're getting out of it. Getting 9.6 out of it. Now, keeping in mind, it has not been calibrated. See what happens if I ground reference it. Not pretty much the same, 9.6. So, keeping in mind, this has not been calibrated, aligned, or anything like that. This is just as is, and it's an engineering sample, which never made it into production. So this is actually quite good. Also, with the fact that it has dirty switches. So we know things aren't getting into places where voltage and current aren't flowing into places where they should, at the speeds they should. Well, given what this unit is, being an engineering sample and incredibly rare, with only 6 examples ever built, I need to get permission from the owner before I really clean up any switches or use any chemicals on this or anything like that. So that one's not going to be in this video, but I'm going to reach out to the owner, see what he wants to do. There might be a second video on this. I'm not 100% sure. We'll take a look at the triangle generator circuit here in a minute, and then I'll have to start working on a write-up for the Tech Wiki. Given that I have this unit in front of me, I'm going to take a ton of pictures of it. I have some great camera equipment, things like that. We're going to make a write-up on this, pop it over on the Tech Wiki, and we're going to go from there. Okay, in the effort to try to get this thing functioning on camera, I did get permission to clean the switches from the owner, and I also got permission to tell you guys about Dennis, who is the designer of this particular unit. His website will be linked down below if anybody would like it. And he has Unit 6, and Unit 4 is the other one, is the only other one, which is right here that I know of in existence for this particular unit. So check out the description below this video for a link to Dennis's website, and check out some of the stuff that's on there. Now, I got the switches all cleaned up, and the oscillator was oscillating, but it was kind of stalling out and acting a little strange. I was somewhat confident that this unit worked, or at least worked at one point in time. And given the way the switches were moving, they were just stiff, crusty, and not moving well. So, sine wave still looks a little pointed at the top, but not too terrible. So, I have the top button pushed in, which is actually letting it sit at the bottom knob. So if I twist this knob, we get frequency movement. If I switch them, it would hold on the upper knob and I can start the beginning of the sweep. So I actually have it set to all the way down at the bottom, all the way up at the top. And up at the top, we're at 116 kilohertz, so not too bad. Let's see what we are at the bottom. At the bottom, we are unmeasurable on that frequency counter, so let's move it. So, in checking the frequency with the 3545, we're starting at about 124 hertz, and we're sweeping all the way up to 100 and about 24 kilohertz. So, we have 4 decades of sweep, and because we're on a linear, logarithmic sweep, we're spending the same amount of time per decade. If it was a linear sweep, as the frequency increased, it would sweep faster and faster and faster. Because it's a logarithmic sweep, it's going at a constant rate. So if we watch the scope screen, which I'll zoom in, we'll hit this. I'll push this top knob in, and we'll start sweeping. So now we have it coming in and then going out, coming in and going out. So what I'll do is I'll turn on the sweep blanking. Now as it's sweeping out, it won't show us, but then it's going to sweep in, blank out, and come back. Now we can turn up the sweep rate, make it come in quicker. And then with the sweep rate control, I can turn this all the way down. And we'll let it come in a lot slower. Turn off the sweep blanking. And now we'll see it come in, and then it'll bounce back. All right, so troubleshooting-wise, what was wrong with this thing? Why wasn't it sweeping in the beginning? Well, we've talked about this a few times on the channel, but we just got bit by it again. And so as part of the troubleshooting process, one of the things you can do is check ICs thermally with a thermal camera or a calibrated finger. In this case, foreshadowing, I don't have the thermal camera, maybe. We'll call it back-ordered for an extended period of time, future video. So I was left with the calibrated finger. As soon as I tapped this op amp, everything started working. The unit popped to life, everything started sweeping, doing everything that it was supposed to do. I have a sneaking suspicion that the socket that this op amp is in, obviously the op amp's functioning, but the socket that op amp is in is one of those TI sockets that is absolutely awful. So to get around I believe it was a Motorola copyright, they grab the sides of the pins, so the IC pin comes in and the socket grabs on the side. It is not a very good connection. TI sockets, if they even smell like trouble, and they're that old vintage TI design, get them out, get a good socket in there. Modern TI sockets, absolutely amazing. Love them, have giant piles of them in the storage bins of the lab. Vintage TI sockets, especially these side pin grabbing sockets, are always trouble. My AA501 is loaded with them, and I'm kind of nervous of the day where I have to tear it apart and resocket every IC in that unit because I have some more socket problems. If you think it might be a socket problem, usually pulling the chip out and reseating it will make it come good for a while. If that does help, just for long term, sockets are cheap. Throw the socket in there and call it a day. Good desoldering tool makes that job infinitely easier because can sometimes be quite a few pins. These red sockets that were used in here, these are extremely high quality sockets. They're a round pin design. Haven't had much trouble out of those, at least from some of the gear that I've repaired. But these TI ones, they're trouble. So, thanks for stopping by the lab, taking a look at this FG506, a device that almost was, but never made it fully into production. And hang around, hit all the YouTube buttons, like, subscribe, and drop a comment. Let me know how we're doing. If you'd like some additional content, take a look at the Patreon page. Patrons are running a little bit ahead, and their support to the channel cannot be thanked for enough. I'm eternally grateful to all the patrons who support the channel, and they help keep the lights on in the lab and help me get YouTube videos out to YouTube. All the support goes right back into the channel, bringing more videos out and helping push things forward. So, as always, I will see everybody in the comment section between videos. Let me know how we're doing, and more is on the way. See you guys in the next one.